This is the Daily Tech News for Monday, May 5th, 2025. We tell you what you need to know, follow up on the context of those stories, and just try to help each other understand.
Today, a U.S. government leak related to Signal that's yet again not a weakness in Signal, and Tom explains what a CPU is.
I'll try. I'm Tom Merritt.
And I'm Robb Dunewood.
Let's start with what you need to know with the big story. Friday, Reuters reported that former U.S. National Security Advisor Mike Waltz was using an Israeli app called Telemessage. Waltz was the official who accidentally added a journalist to a group chat on Signal, so what apps he uses are of note. And Telemessage uses modified versions of Signal. So people were like, oh, is that the version of Signal that he was using? Telemessage is a product marketed to governments that can preserve encrypted chats on Signal, WhatsApp, and other messaging services. Now, you need to do this if you're in a government because governments like the United States have laws requiring that official communications be preserved. So archiving is not the problem. And Telemessage is been around for a long time. It markets itself as a convenient and secure way to archive your government messaging. It's marketed to governments. It operates by adding itself as a third party to conversations in modified versions of the apps so that it does not break the end-to-end encryption, but can send messages from those chats to an archive. It's all end-to-end encrypted, and the archive is supposedly encrypted. Except over the weekend, a hacker who saw this Reuters story thought, let's poke around and find out. That hacker told 404 Media that they had accessed archived chat logs from Telemessage's AWS instance in Northern Virginia. Now, whether they weren't properly secured, whether he was able to phish somehow a key or something, we don't know. But this hacker was able to get into the AWS instance. They could not access messaging from any individual user. They got chat logs, but the chat logs did contain parts of conversations. Now, those conversations were between congressional representatives talking about cryptocurrency, but they were conversations that were supposed to be kept secret. Data related to the U.S. Customs and Border Protection Agency was in these chat logs, Coinbase information, other financial institutions information. Again, these are chat logs, so a lot of information, but not any direct messages, and none of it contained any data from U.S. cabinet members. The hackers said they wanted to see what Telemessage's security was like, and it took them about 15 to 20 minutes to access this archive. They did not alert Telemessage before making this public because they said they were concerned it would be covered up. And once again, it's not a weakness in end-to-end encryption, but the actions of a user that cause this third-party service to be breached. Now, that could be the user using Telemessage. It could also be the user, meaning the way they have installed their archiving on AWS. Rob, what do you think?
This would be a big story from a tech standpoint because this is a messaging platform that the government is using. But it is a much bigger story just because of who was using Signal and how they were using Signal, in proper ways just a few weeks ago, actually, a little over a month ago. So this is a problem. They've got to get this fixed. But I think that a lot more people have their eyeballs on this just because of where Signal is right now. And Signal keeps taking, I don't want to say they're taking L's because none of this is their fault. This is not a Signal thing.
Yeah,
but they're associated with it. So it's kind of like one of those situations where Signal's in trouble because their name was just in this story, even though this has nothing to do with Signal other than Signal is the platform that's being used.
I could not find reliable confirmation that Telemessage was or was not an authorized app provider for governmental use, but it does have contracts with the U.S., so it could have been. So let's just assume for the sake of argument it was, that the use of Telemessage wasn't the problem. A hacker over the weekend taking 15 to 20 minutes to find the ability to get into archived logs, when you're talking about government officials, implies to me that other motivated advanced persistent threat type organizations probably could have done this and probably have done this as well.
Yeah, I was going to say it's not a probably. This is probably we could we could almost, I don't want to say with 100% assurance because you can't be 100% about anything, but it is very, very probable that some other folks have taken a look at this just because of the speed at which it was done by somebody who say, I kind of wonder if I could get in. Oh, yes, I can.
Yeah. So my question becomes, what uses is Telemessage's version of this approved for? Should it continue to be approved for those uses? And have they been able to patch this so that you can't get into those archive logs? This is the kind of thing that there may not be anything wrong with Telemessage itself. How many stories have we run into where somebody misconfigures a container on AWS because they didn't think anybody was looking, and causes this sort of thing? They weren't able to get into the system itself. They were able to access chat logs. To me, that could be fished out of somebody, which is a harder problem to fix, but less concerning to Telemessage's total infrastructure.
Yeah, this is a story that I don't believe is going to go away anytime soon, that, folks are going to look into this. And you have to. This is the federal government is using this platform. It's been breached. You have to figure out how and why and mitigate it from happening again.
Yeah, no, absolutely. So if anybody has any insight into this one, if I know we have some folks who work in this area and you feel comfortable sending us a message, by all means, please do. feedback@dailytechnewsshow.com.
DTNS is made possible by you, the listener, thanks to Philip Shane, Paul Boyer, and D. Laser.
Yeah. There's more we need to know today. Let's get to the briefs.
Apple will change how it announces its new iPhone starting in 2026, according to the information analyst Ming-Chi Kuo. They say Apple plans to launch its foldable iPhone in September 2026. The foldable will be a book-style phone, possibly with a 5.7-inch cover screen and an 8-inch display when open. That will come along with the release of the iPhone 18 Pro models, as well as the iPhone Air. The 18 Pro models will supposedly also get under-screen Face ID sensors. So the big change to all of this is that the base model iPhone 18 will not be announced until spring 2027, along with the mid-range iPhone 18e. Kuo says this is to compete better in China, where Android phone makers often release new phones toward the beginning of the year.
And 2027 marks the 20th anniversary of the iPhone. So this makes sense that you'd have a change and some big stuff happening in 2027. It's not that big of a change to say the base model iPhone goes from fall to spring, but it does lengthen that upgrade cycle that people who always get the base model are used to, which is every September I consider whether I need to upgrade or not. Now you have to wait until March. And the Pro models being separated from the base models is interesting in the cadence. This is probably only interesting to people like you and me who follow this stuff really closely, and maybe like super iPhone fans, but it is a big change. I think people don't realize just how much of a pattern Apple falls into.
I think that there are going to be some Android folks who are going to say, see, you guys are fractured just like we are. And no, I don't think that's the thing that you can take away from this. That is not what's happening here. They're just changing their release cycles. What is very different, though, is that Apple is going to release a foldable. And I know that there are a lot of folks who are happy to see that come, because other devices that fold in half, or in some cases even fold in half twice, are really popular right now.
Yeah, and this will be a test of whether Apple continues to maintain its magic of being late but doing it better. A 5.7-inch cover screen and an 8-inch display doesn't sound that different to me, but again, this is advance information from reliable analysts, not an announcement. I'll be curious how Apple pitches this to say, we did foldables right. We'll have to wait a couple of years to find that out, a year and a half or so, but I'm very curious how that pitch goes. Without getting too far into quantum computing, one problem that it has is that information stored in a quantum state can be affected by processes outside the computer to decohere. In other words, you could have a qubit in a position, and then something outside the computer causes it to not be in that position anymore. It's why error correction is so important in quantum computing. And one of the things that really slows down the size of the computers, because you have to have so much error correction. Well, scientists from Germany, the United States, and the Czech Republic have discovered how to use chromium sulfide bromide to store quantum information in a single dimension, which reduces decoherence. Chromium sulfide bromide can be created to be 1 atom thick, so a big long chain. This prevents particles in the atoms from colliding and interfering with each other. They were able to use magnetism to show you could store information using chromium sulfide bromide. The next step would be to use photons and phonons for processing and transmission. Paper was published in the journal Nature. The upshot, Rob, is that this could make quantum computers less error prone and allow them to be bigger.
It absolutely can. And it's just cool that this is physics happening in computers. It always has been that way. But I don't know that regular folks think about the physics that are happening. We're talking about things that are an atom thick.
Yeah.
So yeah, when you think about physics, the fact that something is so small that if something touches it, it's no longer in the same place that it was before, that changes everything. So this is really cool science. I'd like to see more studies and how this comes out in the future. The coding platform Cursor has become the poster child for vibe coding, but Apple and Anthropic would like in on it. Bloomberg reports that the two companies are working on a new version of Apple's Xcode platform that will use Anthropic's Sonnet model to write, edit, and test code for programmers to speed things up. The platform will supposedly be rolled out internally at Apple first.
So vibe coding is a thing right now, and it's not surprising to see Apple get in on it, but Apple was supposed to have its own internal AI-assisted coding for Swift, and it never rolled it out. So I don't know what this says about Apple's internal AI development.
I don't know what it says, but the more things that I see and the more things that I hear about Apple and AI, it's making me wonder, is this stuff coming out when they're saying it's coming out? It's already been pushed back until at least 2026. Some are saying 2027. It's got my eyebrows up. This is usually not the modus operandi for Apple.
Yeah. 404 Media reports that a leading non-consensual deepfake site, like a site where people would make deepfakes of other people without those people's consent, called Mr. Deepfakes, has shut down. The site posted that, quote, a critical service provider has terminated service permanently. Data loss has made it impossible to continue operating. We will not be relaunching. Germany's Der Spiegel recently reported that a 36-year-old Toronto person was behind the site, but there's no reports of any legal action. It seems like one of the service providers just decided, you know what, we don't want to be involved in this anymore.
If nobody hosts your stuff, it makes it hard to have stuff hosted. I mean, that is a real problem for them. We've noted a lot of tech companies had big earnings as companies and consumers stocked up on electronics in advance of U.S. tariffs. Foxconn reported a 25.54% increase in revenue in April compared to last year. Foxconn is based in Taiwan, but has factories in mainland China, India, Brazil, and elsewhere. It is the major manufacturing partner for Apple, and it says it expects to continue to grow into Q2 as well.
That's the big one, right? Foxconn is confident that it can overcome the uncertainties. It put in the normal, we could be wrong because a lot of stuff is uncertain that everybody's putting in their earnings reports now, but they weren't projecting a downturn, which is interesting.
That is interesting because you would think that if the iPhone, which is a lot of what they do, is moved out of one country to another place, that there's got to be a doldrum. And if they're saying that there isn't going to be, it's like, okay, well, where's the rest of your manufacturing going to come from?
Yeah. France's Eutelsat, which makes the OneWeb satellite internet service, announced that its CEO, Eva Bernanke, will be replaced on June 1st by a longtime Orange Telecom executive, Jean-Francois Fallacher. OneWeb has launched close to 650 satellites, but Starlink's got 7,000. So OneWeb still has a ways to go to catch up.
Got a ways to go, but you got to start somewhere.
That's right.
Waymo said it received its last batch of Jaguar I-Pace SUVs at its factory in Arizona. Waymo is testing two new models using the Hyundai Ioniq 5 and China's Zeekr RT minivan. It says it has 1,500 Jaguars operating across its four main autonomous car service markets in Austin, Los Angeles, Phoenix, and San Francisco. The company plans on adding 2,000 more vehicles to its fleet by sometime in 2026. Waymo says it has an average of 250,000 paid passenger trips per week.
I'm starting to think Waymo is real. Not that I don't believe that it has cars that could take you around, but we're seeing it finally expand. It's considering other cities, still mostly US, North America based, but these are the kinds of services you're really only seeing spread in China and the U.S. right now. But they are becoming regular things for people.
250,000 passengers a week. That's like 4 football stadiums filled to capacity every single week. That's a lot of folks.
One last farewell, as today marks the day Microsoft shuts down Skype after 23 years. If you're listening to this on Tuesday morning, it's already gone. And so you will be too late for this next message. But if you're listening on Monday, you can transfer your data from Skype to Teams or download it to use in another video calling client.
Do we need to pour one out for Skype?
One last time. Pour a little.
One last time. And while Apple must comply with the U.S. judge's order to let app developers link out to alternative payment methods, the company has filed its appeal with the Ninth Circuit.
Yep. So just dotting the I's and crossing the T's there. Apple has filed its appeal. Doesn't mean that it won't be letting you link out for now, but if they were to win on appeal, that could change. Those are the essentials for today. Let's dive a little deeper.
We've been hearing a lot about chips lately. When you're hearing about people making chips or packaging chips, that can mean anything from RAM to a CPU. So Tom took some time to explain exactly what is a CPU, Tom.
How many times have you heard the word CPU? And how many different ways have you heard it? Probably more than you thought. Some people use CPU to refer to the main chip inside a computer. Others use it to refer to the whole motherboard. I've even heard people refer to the entire computer case as the CPU to differentiate it from the monitor and the keyboard. But it's actually the smallest of those. CPU stands for Central Processing Unit. And most modern computers have more than one on a single chip to improve performance. Those are called multi-core processors. When you hear the word multi-core, that means actually multiple CPUs on one chip. Fundamentally, the CPU processes instructions. Almost everything you do on a computer or a phone or a tablet or a game console is coordinated by the Central Processing Unit. Alan Turing pioneered the idea of storing programs so that computers wouldn't have to be rewired in order to do more than one thing. Many people, including Turing himself, tried to make practical versions of this. John von Neumann published a practical outline for a stored program computer called EDVAC. That stood for Electronic Discrete Variable Automatic Computer, EDVAC. He published that on June 30th, 1945, and so he's generally credited with inventing the CPU. Several other stored program computers were finished before EDVAC, though, so he thought of it, but he didn't finish building it before the Manchester Baby and the Harvard Mark I. The Harvard Mark I represented an alternative to von Neumann's conception, though. The Harvard architecture combined memory for instructions and data together. The von Neumann architecture had separate storage and treatment of instructions and data. Now, most modern CPUs use a version of that von Neumann architecture, though some specialized embedded systems still use a Harvard-style architecture. A team at the University of Manchester, because I know you're like, wait, what was the Manchester Baby? Can you talk about the baby? Team at the University of Manchester under Tom Kilburn developed a form of memory to store programs based on cathode ray tubes. Those are the same tubes that used to be used in those big televisions and monitors, like you had in the 50s through the first decade of the 21st century. The Manchester Baby successfully ran its first program on June 21st, 1948. It took 17 instructions and 52 minutes to produce the highest proper factor of 2 to the 18th power. So it wasn't fast for our standards. It was pretty fast for the time. The success was reported in the journal Nature, which was published in September 1948. F.C. William and T. Kilburn's Electronic Digital Computers. He beat Alan Turing's ACE project at the National Physical Laboratory. So in 1948, Turing said, well, I'm going to go to the University of Manchester and join these guys. They're fast. Kilburn oversaw the development of a series of innovative and pioneering computers known as the Manchester computers. While there are many other computers that help develop the form of the CPU, the Manchester computers have a direct line from the first stored program computer to the first transistor computer. Up until the transistor, processing was carried out by valves or electromechanical devices. The transistor computer let designers put all the parts of the CPU in a smaller, easy-to-identify location that you might recognize today as a CPU. The CPU is basically almost the entire organization of everything before that. Now you could put it all in one place. It was two electrical engineering graduate students born halfway across the world from each other that made it happen. Richard Grimsdale was born in Australia, but went to Manchester Grammar School and received his bachelor's and master's from the University of Manchester and was working on a doctorate. And Douglas C. Webb was born in Ontario, Canada, but he got his bachelor's degree at Queen's University in Kingston, Ontario, and was studying for a master's at the University of Manchester. Under the supervision of Kilburn, the two graduate students built and demonstrated the Metrovic 950, the world's first computer made of transistors, in November 1953. It was similar to an older Manchester computer called the Mark I, but used transistors instead of using vacuum tubes. Because the prototype Metrovic 950 didn't include a register, it was actually slower than the Mark I. But a register would be added later, making it faster, smaller, and more efficient as a CPU. Grimsdale and Webb would both get their degrees and co-write a paper on the prototype with Kilburn, which is considered a landmark paper in the evolution of the computer, and set the template for the CPU. Of course, designs of CPUs have changed a lot over the years, but the fundamentals are pretty much the same. A control unit coordinates operations. A register, I just mentioned the register supplies the operations and stores the results. And an arithmetic logic unit, or an ALU, performs the operations. The basic steps are fetch the instructions, which might simply be add two numbers, from memory, decode those instructions, and then execute them. The control unit is just looking at the program counter, also called the pointer in x86 processors, to know what part of memory to look at for the next instruction. It fetches the instruction, then adds another program counter, so it knows to go to the next instruction after the next clock cycle. That instruction is given to the binary decoder to be converted into signals used to control other parts of the CPU. The interpretation of the instruction is governed by the CPU's instruction set architecture. So when you hear someone say, well, ARM is an instruction set, that's what it means. It defines that part of the CPU. x86, which I just mentioned, is a different set of architecture, a different instruction set. Fields within each instruction determine what happens next. There's usually a field called the opcode that indicates what operation is to be performed. Then there will be other fields called operands, not to be too confusing. These tell you the values to process, a 10, a 5, whatever. Could be a constant, could be something that is sitting in the processor register, could be from somewhere else in memory. Let's think about an instruction to add two numbers as an example. So let's say the numbers are sitting in the processor register, left there after a previous instruction created them, right? This is part of a program. The last step is to execute the instructions. The control unit enables and disables parts of the CPU based on the decoded instructions. The numbers to be added flow from the register into the active parts of that arithmetic unit, the ALU, which automatically performs the desired operation, in this case, adding them together. That action is called a clock pulse. When you talk about clock cycles, that's what we're talking about. Clock speed is the number of clock pulses that a CPU can do in a short period of time. On the next clock pulse, the result of the execution, the addition of the two numbers in our example, is then outputted according to the instruction, either to the register or to be available for the next instruction, or somewhere in memory where it can be used by other programs or displayed on a screen or whatever. The register supplies the numbers to the ALU. It performs the instructed match based on what the control unit determined, and the output goes back to the register where it can be retrieved for whatever purpose it was requested, like displaying on a monitor. Whatever the case, the control unit then goes to the next number in the program counter to begin the next instruction. I hope this example gives you an idea of how CPUs work. It's either going to sound oversimplified if you actually know a lot about CPUs, or it's going to be a little bit hard to follow if you're new, but it kind of gives you the flow, right? It's like, you know what a clock cycle is now. You know what a register is like. Oh, that's where the number comes from. And then it can go to different places. The CPU just checks instructions and performs operations on numbers to put out other numbers. It's elsewhere in the computer that those numbers turn into graphics or sound or anything else. The modern CPU has some other neat tricks like caching and such to increase performance. They're all varying ways of coordinating the instructions so they can be operated on the fastest way possible. For example, multi-threading If you hear multi-threading, it lets a CPU execute multiple threads of data at once. The CPU or multiple CPUs almost always exist on an integrated circuit, and that integrated circuit may also have its own memory and interface with peripherals, but the entire system of the CPU and its integrated components are called a microcontroller, or more often these days, a system on a chip. When you hear system on a chip, it's all of those CPUs integrated together. Before CPUs, a computer could only do what it was built for. If you wanted to change the program, you had to literally rewire it. The idea of stored programs meant you could change what a computer did without having to rewire it. You just changed the program. But to do that, you needed memory to store the program, and you needed something that could process whatever program you gave it. Turing imagined it. Von Neumann refined the design and made it happen, and the team at Manchester brought it down to size. If you look around you right now, I bet you can identify literally dozens of items with a chip inside them, running some form of CPU or CPUs, and built on these guys' dreams. Hey, we like to listen to you because we make this show for you. So if you have a few minutes, could you fill out our annual DTNS survey? And thanks to everybody who already has. Let us know what about the DTNS family of shows works for you, what doesn't. It's fun to do, has questions about Pi, and it really helps us shape the show. So go get that right now, if you haven't done it already, dailytechnewsshow.com/survey.
We end every episode of DTNS with some shared wisdom. Today, Icer has a question to help us understand.
Yeah, he writes, I'm listening to Friday's episode and had a quick question. This is obviously a big win for developers regarding Apple's, the judge forcing Apple to require them to allow developers to link out to alternative payment systems. This is obviously a big win for developers, Iser writes, no longer having to pay the 30% cut to Apple for in-app payments. But from a consumer perspective, how much of a difference do you think this will make? Do you anticipate a trend where more apps start directing users to pay outside the app, or will most stick with in-app payments for convenience? Also, I'm wondering if app developers might offer better deals or promotions for payments made outside the app. I imagine Apple will continue trying to keep users inside the app ecosystem as much as possible. Curious to hear your take. So a couple things we know for sure. You will still have to offer the Apple in-app payment system. So I imagine a lot of people will go with that, even if there's another option, because it's easy. Companies can, under this order, say, hey, pay 30% less by clicking here and going outside the app. But again, you'll be going outside the app. That may scare a few people off, and they may be like, even though I'm going to save money, I just want to stick with what I know. And some developers won't want to maintain other payment systems. And so they'll just stick with in-app payments. I'm guessing the biggest companies like Spotify, who already has implemented this, are going to be the big beneficiaries, whereas smaller developers who don't want to have to develop their own payment systems may stick with the Apple payment system. Rob, what do you think?
I know that Apple is appealing this, but let's say the appeal doesn't go the way they want it to go. Could we see Apple maybe lower their fees for the App Store? Because you are right. There are people who would just rather stay in the App Store because it's just easier for them. But if over time, it's like, well, wait a minute, they're charging me 30%. This place is only charging me 17. 30 minus 17 is 13. If I make 13% more, that's a lot of money. So yeah. I wonder if you could see Apple where they may ultimately change the way that they do things if their appeal does not go the way that they want it to go.
Yeah, let's assume that appeal does not go Apple's way. I wonder if they can get away, and again, this could land them back in court if they did this. I wonder if they could get away with giving a discount to people who exclusively use their payment system. So use our payment system and link out, it's 30%. Use our payment system exclusively, it's 25%. Like, is that Apple's really been pushing this to the edge, to the point that the judge believes that one of their executives lied during testimony. So I wouldn't be shocked if that were the case. The only reason they wouldn't do that is they are already going to take a hit on revenue from the App Store because of this. It may not be a huge hit, but they'll take a hit, and they may not want to take more of a hit.
Yeah, the judge was not happy at Apple. I mean, they're basically saying, we may find you in contempt of court for the way that you're acting. Yep. So if Apple just continues to do what they've been doing, that absolutely makes sense that they might actually try to, hey, if you stay in our store, we'll give you a discount. So that would not shock me at all.
We're not charging you for going outside. We're just giving you a discount for staying inside.
Right. So, folks, we love to know what you're thinking about. And if you've got any insights to any stories, you can share it with us at feedback@dailytechnewsshow.com.
Big thanks to Iser for contributing to today's show. Thank you for being along for Daily Tech News Show. It's made possible by our patrons at patreon.com/DTNS. Don't forget, you can get it ad-free if you're a patron or through Substack. You can find out more about that at dailytechnewsshow.com/survey. Talk to you tomorrow.
The DTNS family of podcasts, helping each other understand.
Diamond Club hopes you have enjoyed this program.